Welcome to The Explainer. Today, we're digging into what is, without a doubt, one of the most critical parts of any AI project, data preparation. It's the stuff that happens behind the scenes, the work nobody gets trophies for, but it's what determines if your project actually takes off or just sinks. And look, this quote from the CPMAI methodology, which is a major framework for managing AI projects, that's not just some friendly advice, it's a hard stop. And why is that? It's simple. Charging ahead with bad data is the #1 reason that super expensive AI projects completely fail. It's the ultimate measure twice, cut once rule for AI. And that really is the core truth of it all. Data prep is the hidden work that determines everything. You know, if you get this part right, even a pretty simple model can work wonders. But if you get it wrong, well, you could have the most advanced algorithm in the world, and it would basically just be guessing in the dark.
So let's pull back the curtain on this unseen foundation. We're not just talking about cleaning up a few cells in a spreadsheet here. This is about architecting the actual fuel that your AI is going to run on.
This is the big question, right? It's what every single AI team has to figure out. And the solution isn't some kind of magic bullet. It's a clear, strategic process that we can actually break down into a pretty simple blueprint. So, to bring some order to all the chaos, let's look at a really clear 3-step blueprint. And this isn't just a random list of things to do. It's a logical workflow for turning that messy, raw data into something an AI can actually learn from. So here it is. This is the workflow, and it makes a ton of sense when you think about it. First, you cleanse the data, fix everything that's broken or messy. Then, you augment it to make it even more powerful. And finally, data engineering comes in to turn all of this into a repeatable, automated pipeline. For now, though, let's really zoom in on those first 2 steps, the hands-on work of cleansing and augmentation. Data cleansing? Yeah, it's way more than just hitting delete on a few bad rows. It's about making some really tough, strategic calls. What do you do with missing data? Do you guess what should be there, or do you just toss the whole record out? And how are you going to handle the famous V's of big data? The sheer volume, the velocity it's coming at you with, and the wild variety of it all without your entire process just grinding to a halt.
All right, so once the data is clean, we move on to augmentation. The whole goal here is to make your clean data smarter. Can you add more context, what we call metadata? Can you transform it somehow to create even more training examples? But honestly, the most important question on this slide is about scale. If your plan is too expensive or too time-consuming to repeat, the project is basically dead in the water before it even starts.
Now, inside this whole data prep process, there's one activity that is so important we have to give it its own spotlight: labeling. If data is the fuel, then you can think of the labels as the instructions that teach the engine what to do with it. So what exactly is a label? Well, it's the answer key you give to the AI. For a supervised model, you feed it an image of a cat, and you also give it the label cat. You do that thousands and thousands of times, and it starts to learn what a cat looks like. That label is the ground truth. It's the correct answer you're training the model to find all by itself. And getting those labels right, well, that's a whole process in itself. It starts with collecting the right data. Then you define your annotation strategy, like what are you actually labeling? Next comes the crucial human-in-the-loop step, where actual people apply or verify those labels. And finally, you need rock-solid quality assurance, because you have to remember, low-quality labels will just teach your model how to make high-quality mistakes. Now, since manual labeling is so expensive, a ton of innovation is focused on finding shortcuts. Think of it like this. Self-supervised learning is kind of like giving a model a giant library and just telling it to learn the rules of grammar all on its own. It's how these huge foundation models get built. A more common approach, though, is semi-supervised learning. This is where you give the model a small, human-graded answer key to help it grade the rest of the library all by itself.
So we have the blueprint. But what about the tools we can use? And does all this stuff actually work in the real world? Let's take a look at how modern AI is helping prepare data for other AI, and then see some proof from some pretty big projects.
Generative AI seems like the perfect assistant for this kind of work. It can summarize things, spot patterns, and maybe even intelligently fill in some of that missing data. But, and this is a huge but, you have to be incredibly careful. These models can hallucinate. They can confidently just invent facts,
or subtly manipulate your data in ways you won't even notice. Using them without rigorous human oversight is just a recipe for disaster. And here's where the theory really meets reality. To predict jet engine failures, NASA started out with data from 21 different sensors. But through all their testing, they realized 6 of those sensors were just adding noise, not useful signals. And get this, by removing that data, the model's accuracy actually went up. It's the perfect lesson. More data is not always better data.
Here's another fantastic example from Coca-Cola. For a model to recognize their brand content, they pulled images from public sources, used crowdsourcing for the labeling part, and then did 2 really key prep steps. First, standardization. They made every single image the exact same size. Second, augmentation. They transformed the images to create a much larger and more robust training set. This is the blueprint we've been talking about, just in action.
So this brings us to the final and maybe the most important part of the entire process. After all this work, you have to make a critical call, the go/no-go decision.
This right here is the most disciplined part of the whole thing. It's about having the willingness to hit the pause button or even to go backwards when you run into a major roadblock. Pushing forward with bad data doesn't save time. It absolutely guarantees you'll waste time and money building something that's just doomed to fail from the start.
And this decision shouldn't be based on just a gut feeling. A decision matrix like this one makes it really concrete. For instance, if you realize that the labeling work is going to completely blow your budget, the answer isn't to just push forward and hope for the best. The right answer is to loop all the way back to phase 1 and narrow the project's scope. This discipline of iterating is what separates successful AI projects from expensive failures.
So we'll leave you with this one question to take back to your own work. It's the ultimate reality check. Before you write a single line of code for your model, you have to ask yourself, is the foundation that I've built strong enough for the structure I want to put on top of it? Because at the end of the day, that answer determines everything.